Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. Everybody, welcome to the class. Yes, I am live. So very good evening students. So today we are going to do most important and little bit critical questions of chemistry. So by critical, right, what do we mean by critical? Maybe some combination of concepts will be there. Maybe it will be very lengthy. It will be difficult to predict what actually to do in that question. Okay. Sometimes you read out the question, you don't know how to start the question itself. Right. Those kind of question I have picked up for you. Even those kind of questions, in some questions you will see that, okay, this is very simple, easily I can answer that. Mostly in organic chemistry that happens. You see a reagent, you predict something else, but in reality, something else is the answer, okay? So those kind of questions today I have taken out, right? Okay, yes. Okay, yes, I am ready for the session. Let us start this without wasting any time. Let me know in the chat box if I am visible to you or not. Let me know in the chat box, students, if I am visible to you or not. Right? I am visible, right? Everybody, am I visible? Yes? Everything is clear. Okay, so very few days are left for JEE Advanced, right? Okay, so we have to pull our socks and we have to be completely ready for that. For that, question practice is very important. Without question practice, JEE Advanced you can't do, right? And tough question, twisted question practice is very important here, right? So let us start it. First question on your screen is, for a hypothetical hydrogen atom is there. Firstly, whenever I am giving you the question, okay, so let me know whether you are able to understand what you will do in the question, okay. That's what I'm telling you. When you will see the answer, you will see, oh my God, that was so simple. But when you will read the question, you will get confused at what exactly they are asking, what I have to do here, right? So see whether you are able to predict that what is the formula or what I have to, what are the steps that to be followed in this question, okay? For a hypothetical hydrogen-like atom, the potential energy of the system is given by this. So this is your potential energy of the system, right? This is the potential energy that they have given you, where r is the distance between two particles. So r is the distance between two particles. If Bohr model of quantization of angular momentum is applicable here, Bohr model we are applying here, right? Bohr model we are applying here. Now what we will do, then the velocity of the particle is given by which? I think, I don't know if to me I am not visible or to you also I am not visible. Guys, is the screen blur to you? Is the screen blur to you? I don't know if to me it is happening or to you also this is happening. Right? If there is some problem, then please let me know in the chat box. Okay? Yes. Now, this U is given to you. They are saying the energy of the system is given to you. Right? And they are asking you the velocity of the particle. Right? For these two concepts, you should know about this. Right? Two concepts you should know. One is the differentiation of this with respect to r, because r is the distance. So energy, the differentiation with respect to r is going to be equal to magnitude of the force, which is always for an electron moving in a circular orbit, that is going to be 3 ke square by r raised to power 4. This is from physics that we know, right? 3 ke square by r raised to power 4. Now, this is the first statement. We know that when you will integrate this thing here, let's say I am integrating this thing here. So, this integration will be minus ke square will be in the constant here, right? So, this will be r raised to power minus 3, right? That will be plus 1 here. So, that will come out to be 3 minus 3, right? And this is r raised to power minus 4. So, that is going to be r raised to power 4, right? So this is going to be minus of 3, because here what was there? It was minus ke square, right? This was r, this, its differentiation is minus 3 r raised to power, this is minus 1, so this will be minus 4. So it will turn out to be 4 here. So this will be ke square 3e square r raised to power 4. right? Okay, that you got to know. Now, once you solve this, this is what you got to know after solving this. Okay, this you got to know after solving this. Now, we know that centripetal force, that is mv square by r, that we can equate, right? So, the differentiation of this will be equals to centripetal force because the electron is revolving around the orbit. Whenever electron is revolving around the orbit, it is applying that centripetal force here, right? So, that is why the energy that were given in the question is equal to, the differentiation will be equals to the centripetal force, that is mv square by r. Once you equate this, mark it 1, right? Now we also know that from the Bohr postulate that mv square is equals to nh by 4 pi. That is the angular momentum of Bohr, that is mvr is equals to integral multiple of h by 2 pi. This we know from the Bohr postulate. This we know from the Bohr postulate, right? Bohr postulate, we know this thing. Now, what we have to do, just these two, till here it was a difficult question. After this, this is an easy question. Now, what you have to do, pick out the value of r. R will be equals to nh by 2 pi divided by mv. That will be the value of r. Put this value of r over here, right? Okay, because this is r, this will cancel, this will be r cube. You put this value, you will get this as your answer here after that. Okay, you will get your answer here after that, right? This r value, you will put it here, and hence you will get the value of mv square, right? And then you solve it, you will get the value of v here, right? And this is what they were asking you. So whenever these kind of questions are given to you, what you have to do, you simply have to, this is UR, energy is given to, pick out the differentiation here, equate it with the centripetal force, right? Then you should also know that, okay, this is the angular momentum. Then by these two equations, you will solve the value of radius, velocity, whatever they ask you, you can solve that. Okay, understood? Right? Yes. Next question, let us see. Now, in this question, what you will see, organic chemistry. So there are so many multiple reagents that are given to you, right? So firstly, what reagent is given to you? They are saying you are attacking it with KOH, then after that hydrolysis, then you have PCl5, then you have LiAlH4, then you are adding H positive and you are heating it as well, right? So one by one we will see. So once you have KOH, KOH is what? KOH is going to take out the ET here, right? Ethyl part will be taken out here, right? Base is going to attack here, base is going to attack here, and it will take out the ethyl part from all of these, and you will be left with COO negative, CO negative, CO negative, right? After this, you are doing acidic hydrolysis, right? That means you have O negative, H positive, H positive, H positive, that will be attached here, right? After that, till here it is simple. After that, you add PCl5. We know that this OH will be replaced by Cl, Cl, Cl. So all of them will be COCl, 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 right? Okay. After that, you are doing reduction. So whenever you have COCl, you do reduction, that will be converted to CH2OH. And reduction, it is not Rosenmund reduction. It is LiAlH4, which is a good reducing agent, right? So directly it will convert this to CH2OH, that is alcohol, right? Because it is a good reducing agent, right? So that will be converted to alcohol over here. Now, after this, you are adding H positive and you are heating it, right? In this case, what will happen, right? When you are adding H positive, you are heating it, you will have the formation of all of these. You will have the formation of positive, positive, and positive charge in all these cases, right? So that is why it is going to be a ring here, that is CH2, this is positive, this is CH2, this is positive, right? This is CH2, this is positive, which is not at all a stable formation here. So what will happen? What will happen? This will, the bond shifting will occur here, right? For example, the electrons either shifting here, they are shifting here, right? It will shift here. According to that, these two will join together, these two will join, these two will join. According to that, it will form a benzene ring from here, right? It will form a benzene ring after that because you're also heating it. When you're adding acid, it is getting you the formation of 3 carbocation in one structure, which is not at all stable. So that is why it will lead to the formation of benzene. So the last part is important here. Chances are you might answer this. I think this has the highest probability, but students will fail to answer this thing, that in the end, right, you have the formation of benzene. You don't have the formation of just this OH over here, right? Okay, understood? I can't see anything in the chat box. I don't know why you guys are not at all interested in JEE Advanced. Huh? Let me see if to me you guys are not visible or you guys are actually not interested. When we ask about JEE sessions, then you want JEE Advanced sessions. But when we take JEE sessions, then I feel you guys are not interested in JEE Advanced sessions. I don't know what's the case here, right? So next question is, H2A is a weak diprotic acid. Weak diprotic acid, 2 protons it is giving. If the pH of 0.1 molar H2 solution is 3, pH is given to be 3 of this solution, that is H2A, right? Concentration is given to you, and the concentration of A2 negative is given to be 10 raised to power minus 12. Select the correct answer here. Right, out of the following, you have to select the correct answers or correct answer, whether it's multiple or whether it's one statement is correct. Let us see that, right? First thing is, they are saying that H2A is a weak diprotic acid. Only one thing is given to you, right? Okay, so diprotic acid. So two things will be there. So if you have H2A, right, it will give you, after losing one, it will be HA negative plus AH positive, right? That will be the first proton extraction. After this, you will have HA negative, right? Then it is also going to give one more proton because it is diprotic, and that will be your answer, right? So these are the two equations that you will have. Now they are saying weak it is, okay, fine, that means no 100% dissociation is there. pH of 0.1, H2A solution is 3, and concentration of this is also given to you. Okay. Now what I'll take, initially it is given to be 0.1. Okay, so I'll take it as 0.1. Initial is 0.1, the concentration is. So here what will happen, 0.1 minus x, this is, no. At equilibrium, this will be, because something will be taken out, that is x amount will be taken out. And here x amount is formed, here x amount is formed, right? Because the same number of, if you give one H positive, you will have the same amount of HA negative, right? So that will be X and X here, right? Now, HA is nothing but X. So I'll take it as X, right? Here again, what will happen, because whenever you have simultaneous equilibrium are very important, right? So what you will do, minus Y, and this will be Y will be formed, Y will be formed. Now we know that we have to overall add and subtract here. So what is there? H positive is X, H positive is Y. So I'll add X here, I'll add Y here, right? Both of them will be X plus Y. Here HA is X minus Y, here HA is just X, so it will be X minus Y. A2 negative is not common at all, so we can see this is the final equations that we can write here. So once you have done these things here, then next part, that is just the starting part of this question, okay? Right, that is just the starting part, that you should be able to identify that this is simultaneous equilibrium. After that, again, we will read out this. This is the pH of 0.1, this is given to you, is 3. Concentration of E2 negative is given to be 10 raised to power minus 12. E2 negative means Y is given to be 10 raised to power minus 12, right? Which is very, 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 very small, 0.0000000000001, right? Which is very small. So that is why whenever we are thinking about the concentrations, here Y will be neglected, here Y will be neglected, here also Y will be neglected, here also Y will be neglected. So whenever in comparison to X you have Y, that will be automatically neglected, because you can see here X plus Y is approximately equals to X, X minus Y or Y minus X is approximately equal to X, okay? Because Y is very small, right? Now they are asking you H positive, total H positive from first step of ionization. So first step of, see, we know that first step of ionization H positive is X plus Y. Second step, H positive total is also X plus Y, right? So we know that here this can easily be neglected, right? Because here also Y can easily be neglected from, see, from first step what I have, from first step, H positive from the first step is X, right? From total it is coming out to be X plus Y. Because Y is very small, so we can say these two are approximately equal. So A will be your correct statement, right? So directly how you can answer these kind of questions, okay? Right? Students, see, they have given you H2A, right? H2A is given to you and acid is given to you. Acid wants to donate H positive. So you have H2A here. One H positive it will donate, you will have HA. Right? Second H positive it will donate, you will have A2 negative. Right? So firstly what will happen? Initially it was 0.1. That was given to us that it is 0.1. Right? It will take out X from here. It will form X and form X here. Right? Here you already have HA, that is nothing but X. Right? After the equilibrium state, what will happen? You will take out Y from here, Y will be formed, right? But here, we know that H positive concentration here was X and here it was Y. So both should be equal in simultaneous equilibrium. So here you will add X plus Y, this will also be X plus Y. HA was here X and here it was X minus Y. But in both the equations, it should be equal, right? So we can say this will be X minus Y, this also will be X minus Y. Till here, tell me if that is clear to you. Till here, tell me if this simultaneous equilibrium is clear to you or not. If this simultaneous equilibrium is clear to you, then I'll move ahead, right? Now, Y is given to be very, very small because they are saying A2 negative. That is, Y is given to be 10 raised to power minus 12, which is very small. Please don't spam in the chat box, right? Which is very small, right? Now, because it is very small, that's why X plus Y is approximately equals to X. X minus Y is approximately equals to X because Y is very small, right? Now here, let us see. They are saying H positive total. Total means H positive from first and H positive from second. That is X plus Y. H positive from first step. After ionization, you just had X here, right? So that means, are these two equal? Yes, these two are approximately equal because Y is very, very small here. Okay, because Y is very, very small here. Pratyush, please don't spam in the chat box, right? Okay, please don't spam. Basics you can see on this channel as well. Okay, so let me just focus on the question. Next is concentration of OH negative in the solution is 10 raised to power minus 3. For that, you have to see the H positive concentration, right? Okay, so OH negative, first of all, it is not there only, so that will be automatically not true because it is not there in the solution only, right? Concentration of this, that is not there. See, we know that the pH is coming out to be, pH is coming out to be, if pH is 3, then H positive concentration is 10 raised to power minus 3. How can you say concentration of OH negative? No, concentration of H positive is 10 raised to power minus 3, not OH negative. That is also incorrect. The value of Ka1 is nearly 10 raised to power minus 5. For that, you have to see the value of Ka1, right? So how to find the value of Ka1? This we have done, right? The value of Ka, we know that in this equation, because we are talking about the first equation. So this was the first equation, right? So from here, Ka will be product divided by reactants. Product is Ha, this should be negative here, this should be negative. Ha, right, minus and H positive, that are the products. Reactants are H2A divided by H2A, that are the reactants here. Okay, that are the reactants here. So this is your Ka1. Now students, if you see this, H positive concentration is given to be X. That is coming out to be H positive concentration is 10 raised to power minus 3 here. Right, so I'll just directly put the value, that is 10 raised to power minus 3. Right, Ha negative, if you see Ha negative is X minus Y. Now students, I have told you here that X minus Y is approximately equals to X. X plus Y is approximately equals to X. And what is X? X, they have given that, see, X means H positive concentration, that is coming out to be 10 raised power minus 3. If this is 10 raised power minus 3, this also should be 10 raised power minus 3 only, right? Okay, so because this is also X, this is also X. That positive concentration with the question, it is given to be 10 raised power minus 3. If this is 10 raised power minus 3, this also will be 10 raised power minus 3, right? So I'll just put the value here also, that is 10 raised power minus 3. Now H2A. Now understand one thing. Here H2A concentration, you are taking out 10 raised power minus 3 here, right? You will say, ma'am, that is also, ma'am, that you will say, ma'am, 0.1 minus 0.001, right? Should I do that? See, when you talk about 0.1, that is 10 raised power minus 1. 0.001 is 10 raised power minus 3. So you can also neglect this thing here. So 0.1 minus X is approximately equals to 0.1 only, because X is not very large, okay? X is not very large. So that is the case. That is why we will directly put the value here, that is 0.1, and answer you will get is Ka1 is 10 raised power minus 5. See, if Ka1 is the value of this is true, because it is coming out to be 10 raised power minus 5, pKa2 and pKa1 is 9. That is not true, because if Ka1 is 10 raised power minus 5, then pKa will be equals to pK1 will be 5 here. So that is not the correct answer. So two statements are correct here. That is A and C are the correct statements. Okay, right? Okay. Yes, everybody. Patyush, I have seen your message. Okay. Now, everybody, let me know in the chat box if this question is clear to you or not, right? If this question is clear to you or not, let me know in the chat box if that is clear to you, right? So that I can move with the next question here, right? Your response is very needed, right? Reason being, because these questions are little bit complicated. So I need to see whether you are able to understand what I am telling you or not. If there is confusion in any step, you can always ask me here, right? If there is confusion. Yes, ma'am. Vivid is saying, yes, ma'am, that is clear, right? That is clear, right? Okay, perfect. Next question, let us see. Next, here it is given to be. I'll give you a hint here, okay? That is based on Beckmann's reagent, okay? Beckmann's rearrangement, okay? So now you will say, ma'am, what is Beckmann's rearrangement? So in Beckmann's rearrangement, for example, this is there. This is, let's say, this is OH, and this is lone pair, right? These are oximes, okay? These are oximes. Let's say this is R dash. So here you need to understand what is Beckmann's reagent exactly, what is Beckmann's rearrangement exactly, right? So here what exactly happens here, when you add H2SO4 in the acidic condition, what will happen? Here you will have H, and here also one H will get added here, and here you will have positive. And that is the reason water will be eliminated, and in the answer you will have C double bond N. This is the lone pair. This is the positive charge, this is R, and this is R dash. Rearrangement will occur at this point, okay? So firstly, proton will get attached when oxygen has positive charge. In this kind of situation, you have water will be eliminated. That is what happens in Beckmann's reagent. Rearrangement. I don't know why I'm saying reagent again and again. So here what will happen? Migration will take place. Migration of this can occur or this can occur. You know which migration will occur? The migration of that group that is opposite to OH in the initial product, initial reactant. So here you have OH, so the opposite is R dash, that will be rearranged, okay? So here this thing will be rearranged to this side, and hence what will happen? The answer will be, this is C double bond, this is N, this is R dash, right? And this is R, and this is your carbon will have positive charge here, because now this is the deficient species. That is called Beckmann's rearrangement. Is that clear to everybody? What was Beckmann's rearrangement? Is this thing clear to everybody or not? Right? Okay. right, recommend books for chemistry for 2027 JEE Advanced and other NCRT, please ma'am. Pratyush, one very important thing for you, right? Don't worry, we are going to everything, basics, backlog, everything we are going to cover for you 2026 and 2027, right? So please don't spam here. That will be dedicated video, will be will be made based on for the students who are for 2026 and 2027. But now what you can do on this channel video section, you will see one video for 2026 chemistry, right? That you can watch. That will really help you to understand what you have to do in next days. Okay, right? Now here, what we will do in this case, okay, what will happen here, right? Okay, so I'll just draw the structure here, what is going to happen in this case, right? That was a, see, if you know that what is Beckmann's reagent, this will be very simple question for you, right? So now here we know that this whole group will be shifted to this side. So this is C double bond N, right? This whole group, or you can also shift this place because this group is very large. We know that this group will be shifted, not methyl. If I say methyl is shifted, I could have easily shifted it here. But this is not going to happen. So what I'll do, I'll rather shift this thing here. So that is going to be 1, 2. So that is your one group here, big R group. To this, instead of carbon, nitrogen will be attached here now, right? And nitrogen will be attached to this carbon, which is further attached to methyl, and it having a positive charge here. So that is Beckmann's reagent. See, if you know total Beckmann's reagent, this will be very simple for you, right? Even if you don't know what is the product, then also you can answer this Beckmann's reagent. This will be the answer, but still you should form this product. Okay. So what we are going to do after this, right? After this, we are adding OH negative, right? So what we will do, we will add OH negative here. That will be added to this place. So this is going to be 1, 2, 1, 2. 1, 2, and here it is N, here it is double bond C, this is OH, this is N, right? Okay, now tautomerism, because it is enol, right? So what will happen? This double bond will shift here, this double bond will shift here, and hydrogen will be shifted here, and hence you will have the tautomeric product, that is NHCOMe. That means B is going to be the correct answer here, right? Okay. Yes. Okay. Next question is, they have given you for a cell reaction, this cell is given to you, right? What is the value of delta H of formation of water? And they are giving you one more reaction here. Now let us see what we are going to do here. Everybody firstly see the question, okay, what they are talking about in the question, okay. See what they are talking about in the question. They have given you delta S of first reaction. What is the value of delta H formation of this reaction? Okay. This overall reaction is given to you, where delta S is given to you. It's very simple. Delta S is given to you. They are asking you delta H. See, we know that there is a question. There is a Gibbs-Hammond equation. Delta G is equals to delta H minus T delta S. So they have given you at a temperature, right? Temperature is also given to you, that is 298 Kelvin. Temperature is given, delta S of overall reaction is given. Delta H they are asking you, delta G also you have no idea, right? We have no idea what is the value of delta G here. Now that means we have to calculate the value of delta G here. From where we will calculate the value of delta G, right? Firstly, you should be aware that what they are asking you, right? So that means this I can calculate from where delta G is equals to minus NFE naught cell, right? From there I can calculate, because I can see that two reactions are given to me. For this reaction, they have given you the value of E naught, right? Here I know electrons are getting gained, so this is for cathode. So this is the cathode side. This is the cathode side. And we know that here it is getting added with water, right? That means water is at the anode side, okay? So that means firstly though we have to write the reaction at anode, what is happening at anode. At anode it is losing, so it will be H2 that is losing and it is becoming H positive, right? 4H positive will be there, right? Only then 4 electrons it is losing, because number of electron lost and gained should be equal. That means the value of N will be equals to 4, right? That means the value of N will be equals to 4. Now, if you see, the E naught cell value is equals to E naught of cathode reduction potential minus E naught of anode reduction potential, right? So we know that cathode is what? Cathode is given to be, cathode is 1.25, that also you have to see. Anode will be opposite, that is where you have loss of electron. And we know that in this case, E naught value is going to be 0 because it is standard hydrogen electrode, right? It is going to be 0. So this is 0, so this is going to be 1.23 volt. E naught value you know, right? N value you know, you can put it here, minus 4 Faraday 96500. You can put the value 1.23. That is your delta G naught value. Now this delta G naught value you will put here, right? You will put this value here and then this value easily you can get. Okay, understood? Yes, right? So that you will easily get here by putting all these values. Calculations you need to know. First thing is this thing you should know, that what exactly anode, cathode, what they have given you, that you should be very, very aware of, right? Okay. Next is, as you can see the question here, a cell diagram shown contains 1 liter of buffer solution. So this diagram is given to you, right? Diagram based questions are very important, okay? So it's not like they are very, very difficult, but you need to have a right approach to solve these kind of questions, okay? So a cell diagram shown below contains 1 liter of buffer. 1 liter of buffer they are saying of HA, pKa value is given to you. NaA, that means salt in both the compartments, right? What is the cell EMF? This is what they are asking you. So if you firstly observe this diagram here, what you will see, that here what you can have, this is H2 gas that is liberated, this is H2 gas that is liberated, right? Here we always know whenever two cells are given to you, right? Always this is anode and this is cathode, is it right? So anode and cathode are given to you, right? Anode means here you will have loss of electron. This is your anode and this is first some basic things you should know. This is anode and this is cathode. That is very basic thing. That in salt bridge also, whenever you represent it, it is always AC. On right hand or left hand side you have anode, on right hand side you have cathode. That you should know. At anode, what will happen? We know that there is HA, there is NaA, right? This is salt, this is acid. I can write it here. This is acid and this is the salt. The concentrations are given to you for both of them, 0.1 and 1. Here also you have HA, 1 is the concentration, salt, and this is the concentration that is also given to you, right? This is acid, right? Okay. Now, let us see, at anode side what will happen? It will lose the electrons, right? So that means which will be converted to which thing? So at anode side, the formula, wait a minute, yes. No. Yes. Okay. So at anode side, firstly, you should know what is going to happen. At anode side, it will lose the electron. So that means H2 is getting converted to H positive. That means something like this is happening here. So H2 is getting converted to H positive. It is losing the electrons. So it will lose 2 electrons here, right? That you might get confused seeing these bookish language. That's why I'm written here. H2 is getting converted to H positive. It is losing the electrons at anode side, right? We know that if you want to calculate the value of pH here, right? So directly at pH will be equals to, pH is equals to pKa plus log of acid, log of salt by acid. So salt here is given to be 1, right? And this acid is given to be 0.1, right? So I'll directly put the value pKa, right? That is given to you, is it? pKa value, it is given to you, solution of HA. 1 liter of buffer solution of HA, pKa value is given to be 4, right? So pK value is given to you, that is 4. log of this is nothing but this is salt, and this is nothing but this is acid, right? This is how the formula is, right? pH is equals to pK plus log of salt by acid. Salt is given to be 1, acid is given to be 0.1. We'll put the value, we'll get the value of pH here, right? pH value means the H positive. If pH is 5, H positive concentration will be 10 raised to power minus 5, right? What they are asking you, they are asking you what is the EMF, okay? So H positive concentration you have calculated here. Now we will see at the cathode side what is happening. At cathode side, we know that it will gain the electrons, okay? At cathode side, it will gain the electrons. That means H positive is converted to H2 by gaining 2 electrons, okay? That is happening at anode side. Now again, pH is equals to pKa plus log of salt by acid. But in this case, salt is different, okay? In this case, salt concentration is given to be wait a minute, 1 molar for both. It is 1 for both, so there is no worries, okay? So it is given to be 1 for both, right? So what we will do, directly put the value 1 and 1 for both. Log of 1 is nothing but it is 0, right? pK value is given to 4 in the question. That means pH here is going to be 4. That means H positive concentration is going to be 10 raised to power minus 4, right? Both the concentration now you got. Now, if you see this here, two important things. First is the diagram. They have not given you its diagram is just to confuse you, right? So, first thing is to identify which is anode, which is cathode. Then you are able to solve the concentration of H positive here. That is 10 raised to power minus 5, right? Here it is going to be 10 raised to power minus 4, right? Now, here you need to know, when you want to apply the Nernst equation, you should know what exactly is the product side, which is the reactant side, right? So for that, the overall reaction, if you see half chain reaction, this so we know overall reaction, when you add these two reactions, what will happen? See, this reaction, we know that simple thing is at anode side, at cathode side, you have H positive concentration on the right side. So overall reaction will be H positive concentration of cathode, right? That is on the right side because H2 will cancel eventually, right? H2 we know that pressure is 1 atmospheric only, that will cancel. Here it is on the right side. Here it is electrons will also cancel. If you see electrons will cancel, right? These electrons will cancel. You can also do that, right? H2 will cancel, this is cancel, this will cancel. That we all know, right? But how you can solve this? That is on the right side. So that means H positive concentration of anode, that will be here. So now you have for Nernst equation the left side and the right side. Okay? The left side and the right side. Now if you see, in the Nernst equation, when you want to put Nernst equation, that will be product by reactants, right? We know that H positive concentration at cathode is coming out to be 10 raised to power minus 4, right? And this is coming out to be 10 raised to power minus 5. Okay, that is all you have to put here. That is all you have to put here right now, right? We know that this is also coming out to be 2. In the question, it was 2. Right? When you balance this was 2 only, right? When I was doing it here, it was also 2, right? So that means 2 and 2 will be here, 2 and this is 2. So when I put the value, that is E cell is equals to, we know that if I write it here, E cell is equals to E naught cell minus of 0.059. In fact, the number of electron lost and gained is 2. Right, log of product by reactant. So product is 10 raised to power minus 5 raised to power 2. This is the concentration raised to power 2. 10 raised to power minus 4 raised to power 2. That is how you will solve this. Now, both are standard hydrogen electron. So cathode is also 0 and anode is also 0. So E naught value is automatically equals to 0 here. So we'll put the value of E naught as 0. That is how you will get your answer. So that was a very, very interesting question of Nernst equation. They have not given you H positive concentration product reactants. This you have to solve yourself by pH buffer solution formulas from ionic equilibrium, right? Then you will solve this equation, right? Okay. Right, everybody understood? Is there any problem in this question? Okay, is there any problem here? Then let me know in the chat box if there is any problem here. If there is any problem here, then let me know in the chat box. This we have done. Okay, this we have done. Right? Is that clear to everybody? Students, I want to know your response also in the chat box if that is clear, right? Next is 3. See, this is not at all time consuming. The last question was time consuming, okay? This is not at all time consuming. It's just that one thing should click in your head. It's about clicking. If that thing is clicking in your head, that means the question is easy for you. If that thing is not, you're not able to click that in your head, that means this question is difficult. Let us see how many of you are able to understand what thing you have to apply here. What is the stabilization factor that you have to apply here? Arrange the following alcohols in decreasing order of ease of ionization under acidic conditions. So acidic conditions. See, whenever you have acidic conditions, they are going to take out OH negative, right? Acidic conditions means OH negative will be taken out. First thing is you should know this thing, right? That is OH negative will be taken out. So OH negative is taken out, OH negative is taken out, OH negative is taken out, right? So can I just write here that in all these cases, what you will have is a cation. I'll just write it here only to save the time. I'll just write it here only. Cation, and cation. Okay. So you will have cation in all these cases, positive, and positive. Now, next thing is, okay, ma'am, we have cation in all the cases. Now you have to see, they're asking you ease. That means which carbocation is maximum stability. Now tell me which carbocation is maximum stable. This also you have to be clear on one thing, that this I have to see the stability. Others are same. This I have to see the stability. This I have to say the stability. Right? So double bond, single bond, positive. It has 4 pi electron. It is anti-aromatic. This is a question of aromaticity. Okay? This is a question of aromaticity. Right? Okay? Yes. Now, if you see this here, 1, 2, 3, 4, one lone pair here, one lone pair here. Outer lone pair that is not involved in the delocalization is not involved in pi electrons. 1, 2, 3, 4, 5, 6. 6 pi electrons means this is aromatic, right? Then you have this one here, 1, 2, 3, 4. This is no complete conjugation. This is non-aromatic. And we know that more is the stability, more is the ease of ionization. So answer will be second has the maximum ease because it is aromatic. Then you will have third because it is non-aromatic. Then first, the one that is anti-aromatic will have the least ease of ionization. Okay. So answer is going to be C is the correct answer here. Right. Tell me here you have any problem, students? Any problem here? Right? Any problem? Right? Should I move to the next question? Is that clear? You have to focus on the middle ring here. Right? You have to focus on the middle ring here. Right? Next question, let us see. Chalo, firstly read out this question. Okay? Firstly read out this question, what they are telling you. For a hypothetical reaction, some hypothetical reaction is given to you. Delta H is given to you for first reaction. Delta H is given to you for second reaction. Right? This is 2x and this is x. Okay, that is exothermic, that is endothermic, that is given to you. Right? These reactions are carried simultaneously in a reactor such that temperature is not changing. Simultaneously, first thing is simultaneously they are going on, but the second thing is there is no common reactant or product here, right? That you should remember, right? If rate of disappearance of B is, so now this is a question of where 2-3 concepts they have mixed. Disappearance, equilibrium concept, everything is mixed here. Between little bit of thermodynamics also they have added, right? So mixture of concepts, right? Very important when you have mixed concepts in a question, okay? So if the rate of disappearance of B is Y, mole per second, then the rate of formation of this. Firstly, you understand what they are asking you, right? And what is given to you. Straightforward, one thing is given to me and answer is in terms of y. So I have to know what exactly is this y. Okay. So rate of disappearance of B. B is over here. I know that rate of disappearance is minus dB by dt is given to, because whenever you are calculating appearance and disappearance, you don't divide it by the number of moles. So this will be minus of dB by dt. That is going to be y here. Okay. That you should remember, that is given to you. That is given to you. Now what is asked to you? You have to tell me what is asked to you. Now what is asked to you? They are asking you then the rate of formation of Q. Formation of Q, appearance of Q means d of Q by dt. Formation will be positive. This is what they are asking you, right? Two equations you have, right? Two equations you have, right? One by one we will solve this. First is what is the, we have to equate this in the rate of reaction form. Delta H is given to you. Then we have to, with A I can equate this. See, one very important formula, one very important thing, because they are simultaneous equilibrium is there, right? These two, firstly I have to see, right now there is no reactant that is common. So I have to generate one relation between, with the help of this delta H, I have to generate a relation that how these two are equal to each other, right? So what I can see, this is minus of 2x and this is x, right? This is minus of 2x and this is x. So what I can say is delta, if delta H of A is minus 2x, then that will be half and the sign will be positive. So from this I can generate this relation that the delta H of, delta, let's say this is delta H1, I'll take it as delta H1, this is delta H2. Delta H1, delta H1 of minus dA by dt, right, is equals to delta H2 minus of dm by dt, because these are the two equations that are given to you, right? Okay, understood? So since the temperature is not giving, net delta H for the process should be 0, right? So that means these two should be equal to each other, right? Delta H, the mod of delta H of 1 multiplied by the disappearance of A, delta H2 of second reaction multiplied by the disappearance of the second reactant, that is N, right? Only then, because if these two are equal, only then their net change should be equals to 0. Only then that is possible, right? Okay, first thing, is this thing clear to everybody or not? Right, that is the first thing that you should know here. First thing that you should know, that how I am making a, I'm generating a relation between these two equations here, right? That we have used. Now, after this, according to this reaction, now from chemical kinetics, this you should know, that whenever I have to rate of reaction, whenever I am writing, I'll divide it by number of moles. So I can write the rate of reaction, I'll just write here, rate of reaction will be equals to minus dA by dt, disappearance divided by number of moles, that is 1, equals to 1 by 3, it is also getting disappearance, so it will be minus here, right? This is minus, I'll put the minus here, okay? This will be minus, okay? Minus dB by dt. Now we know that in the question they have given you minus dB by dt is equals to y. That is given in the question. That means this thing is given to be y, right? So that means minus dA by dt will be equal to y by 3, right? Now, if I put minus dA by dt, now I know that minus dA by dt is equals to y by 3, y by 3. This equation I got, right? Now, if I put this value here, if I put this value here, can I get the value of dm by dt here? Because delta H is already given to me. Delta H1, delta H2 is already given to me in the question. That is given to me in the question, okay? Right? So that means I just need to put this value here. Then if I put this value, delta H1 was given to be 2x. I think it was given to be minus 2x, but the mod will be 2x, right? Okay. So this is given to be mod is 2x. This delta H of 2 is given to be X, mod will be X only. This we have calculated to be Y by 3. From there, we can calculate the value of minus dm by dt, that is 2y by 3. Okay, that we have calculated, that is 2y by 3. Now, they are asking you, they have asked you the value of dq by dt. See, one thing is to have the relation between both of them, then you just have to apply rate of reaction. Now, once I have the formation minus dm by dt, then I just need to apply the rate of reaction here. So, what it will be, we know that this is the question, this is equation, minus dm by dt divided by the number of moles, that is 1, right? I'll just write it myself only. So, this will be minus dm by, or I'll just write it here. Rate of reaction you can write, because here it is directly written, so I would not advise you that, right? You need to write it like this. Rate of reaction is given to be minus dm by dt is equals to, in terms of q, because q is what they are asking you, q is getting formed, so this will be plus 1 by 2 dq by dt. That means, can I say that dq by dt, the formation only they are asking you, is equals to minus of 2, or you can say 2 multiplied minus dm by dt. Minus dm by dt is 2y. This is 2y by 3. So, answer will be 4y by 3. That will be your correct answer in the end. Right? Students, tell me, is there any problem in this question? Is there any problem in this question? Then let me know in the chat box if there is any problem here. If there is any problem here, students, then let me know in the chat box. Right? Is that clear to everybody what we are doing? Firstly, what you need to understand is delta H and 2 is given to you. Right? They have specially given you that it is simultaneously in a reactor such that temperature is not changing. Temperature is not changing means they both have equal enthalpies, right? So that's why this relation you should know, that how they are equal to each other. Only then overall energy enthalpy will be equals to 0. Delta H of overall this will be equals to 0. Only then we can say temperature is not changing, right? So this equation we have, this we can calculate from rate of reaction. This we can calculate from rate of reaction, because dB we have given. From there we will calculate dm by dt. And here they have asked you for Q. This is what they are asking you. And B they have given you. From B you will solve this value. Then you will solve this value. Then you will solve this value. Is that clear? Right? Okay. Overall, like what we have done, that also I have told you. Right? Okay. Next question is, the following molecule is fluoromethanol. Metholone. Sorry, yaar. Fluorometholone, right? Okay. Metholone. Okay. So here, this is a very, very big structure. Okay. Nobody is going to ask you to draw this structure. Don't worry about that. This is one of, like, this is not a difficult question, I would say. But one thing you should know here. Just one word you should know here. Right? How many stereogenic centers? What are stereogenic centers? Firstly, tell me that. What are stereogenic centers? If you know this, otherwise this is not a difficult question. If you know what are stereogenic centers. Stereogenic centers are chiral centers. Chiral centers should be sp3 and they should have all 4 groups different. Okay. So if you know what is stereogenic center, you can easily answer this in seconds. So that's why this is, I would consider just one word you should know here. Right? Okay, rest of this, so you can easily answer. Chiral carbons only you have to calculate 1, 2, 3, 4, 5, 6, 7 and 8. So answer will be 8 is the correct answer. Let us move to the next question here. Right. Next is, the following compounds differ with respect to. So now these 4 options are given to you. Right. 2 compounds are given to you. Firstly, tell me one thing. What are these 2 compounds? You can see this is dash, this is solid, this is dash, this is solid, this is solid, this is dash, this is solid, this is dash, this is solid, this is dash. Means everything is opposite here, right? means everything is opposite. So when everything is opposite, can I say these are the mirror images of each other, because everything is opposite, right? So when I say I want to see the mirror image of this thing here, so this pointer that is towards myself, that is towards me, it will be towards you when I see the mirror image here. So that means everything is opposite here, right? So that means they are mirror images of each other. But if you put it here, right, they are non-superimposable. So these are enantiomers, right? They have same chemical and physical properties. They are saying differ with respect of nothing, the direction in which. Now, how they exactly differ? So they are optical isomers of each other, right? One of them is dextro, other is levorotatory. They differ in the direction in which they rotate plane polarized light. One will rotate towards right, other will rotate towards left. So that is the difference that they will have, right? Okay, understood? That is the difference that they will have. So answer will be C is the correct answer. Okay, next question is, now here I also need to show you the options, right? Only then you will be able to answer this. Column 1 and 2 contains 4 entries each. 4 entries are given to you. 4 things are given to you. One or more than one entries of column 1 may be matching with the same entries of column 2. Right now, students, what you need to see here, you have N-hexane, you have N-heptane. Just remember one thing, if you have ideal solutions, right? So firstly, let us categorize this. This N-hexane, N-heptane is ideal solution. Okay. Then chlorobenzene, bromobenzene is also ideal solution, right? Then acetone and chloroform. After this, hydrogen bonding will start, and this will be more interactions you will observe. That is why this is negative division. This is negative division. Okay. And here what you will see, it will break eventually and you will see positive division here. Right? Okay. Now, can be separated by fractional distillation, maximum boiling azeotrope. Firstly, you have to see the options also here. But I'll tell you, hydrogen bonding, negative division means you have pressure is less. Pressure is less means boiling point will be more because they are inversely proportional. So it will be maximum boiling azeotrope, right? So this is going to be maximum boiling azeotrope. This is going to be minimum boiling azeotrope. That is opposite. Right. Now let us see the options here. Let us see the options here. A is PP, 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 P. Yes, A is, all of them are saying PP, PP, P. So P is basically can be separated by fractional distillation. Right. Okay. So if you see cannot be separated, two options we have here. Chalo, theek hai. So A is definitely ideal solution that can be separated by fractional distillation. Right. Then B is you have Q and R, here you have Q and R, here you have SR, here you have only R. Let us see R. R is what? Cannot be separated by fractional distillation. That is also true. Because non-ideal solutions, you can't separate that by, see, ideal solutions will have no interactions, right? So that is why they can be separated by fractional distillation. But here, these, when they form like more interactions or less, they cannot be separated by fractional distillation. And then out of S and P, they are maximum boiling azeotrope. So answer will be Q, right? So Q and R is the correct answer. That means these two are eliminated, right? Then C is what? P or R? C is chlorobenzene. Again, it is P. It can be separated by fractional distillation. Right? Okay, so this is also eliminated. Right? Last is these R and S. These R and S. D is R cannot be separated. S is minimum boiling azeotrope. So answer will be A is the correct answer here. Okay? Right? A is the correct answer here. That's how to solve these kind of questions. Okay? Right? Yes? Okay. Now let us see this question from organic chemistry, right? Let us try to solve this question from organic chemistry, everybody. Let us try to solve this. So here they have given you an isomer of C6H12 gives total 6 isomeric products on monochlorination. So whenever monochlorination means only one hydrogen will be substituted. Best part is here, this is also given to you. Chances are in the exam, this will not be given to you in the exam, right? In the exam, this will not be given to you. This you should remember that degree reactivity of 1 degree is 1, 2 degrees 3, 3 degrees 5. That you should remember yourself, right? Okay. An isomer C5H12 gives total 6 isomeric products on monochlorination. First is you have to see pentane has how many isomers. So it is 1, 2, 3, 4, 1, 2, 3, 4, 5. This isomer it has, then 1, 2, 3, 4. This isomer it has, then 1, 2, 3. This isomer it has. So you need to have that isomer which is showing you 6 isomeric products. Okay, so here if you see, definitely not 6. So this is CH2, this is CH2, this is CH2, this is CH3, this is CH3. Monochlorination will give you 1, 2 and maximum 3 kind of products. Okay, 3 kind of isomeric products. So it's not possible. N-pentane is not possible. Let us see isopentane, right? This is CH3, this is CH3, this is CH2, this is CH3, this is CH. So if you see this here, this is a different thing, right? This is a different thing. They both are same, 1, 2. This is a different thing, 1, 2, 3, 4, right? This is also giving you only 4. Wait a minute. No. So if it is connected here, 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 1, 2, 3, 4, 5. So let us see this thing. It is going to not give you so many. So this is going to give you 6 isomeric products. Wait a minute. Let me see. CH3, this is also not going to give you so many isomeric products. This will only give you one isomeric product. So neo is definitely not possible, right? I think the possibility will be this one, but let me see what is the okay, 1, 2, 3, 4, 5, 6. Even 1 or 2 will be substituted. That will be 1. 1 or 2 will be substituted. That is 1, right? Chances gives total 6 isomeric product or monochlorination. 1 chlorination will be there. Okay. So product will be that only. This will be iso is only possible because that is only giving you maximum isomeric product. I think that will be something cis and trans. I am saying that is because of maybe the stereochemistry of this thing, right? That it is giving you 6, right? Okay. Yes, that might be the stereochemistry, right? Okay. Now we have choose that as your the one that is the isomer that is giving you 6 isomeric products on monochlorination. Calculate the percentage yield of the primary monochloride which is chiral. So you have to see primary monochloride which is chiral. Okay, so firstly you will select this thing. Now you have to do the substitution and you have to see what are the different types of substitution that is possible. So I'm going to draw it again, right? So this is 1, 2, 3, 4. Okay. How they will give you different things, right? So this is CH3, this is H, this is CH2, this is CH3, right? Okay. That is a thing that you will have. In this particular compound, you have to check the primary, the secondary, the tertiary hydrogens. Okay, you have to check the primary, the secondary, the tertiary hydrogens. Okay, so when we are selecting the primary hydrogens, that is only connected to 1 carbon here, right? So that is primary, only connected to 1 carbon, only connected to 1 carbon, 3, 4, 5, 6, 7, 8, 9. 9 hydrogens you have. 2 degree, that is connected to 2 carbons. That is connected to 2 carbons. That is 2 here, right? So that is 2 hydrogens. 3 degree, that is only 1 hydrogen, that is 3 degree here, right? So this is 9, this is 2, this is 1. So overall multiplication you have to do. That primary hydrogens are 9, so that will be overall reactivity will be 9. This is overall will be 6. This overall will be 5. Okay. Understood? That overall will be 5. Now they are asking you primary monochloride. Okay. Primary monochloride. Primary is this. Primary is this. Primary percentage, because they are asking you percentage. That's why I have to calculate everything here. Primary percentage they are asking you. So in this case, it is 9, but you can't say 9 divided by 9 plus 6 plus 5 multiplied by 100. No. Primary monochloride, which is chiral. They are asking you which is chiral. So you have to see the primary ones here. Right now, I'll again delete it. Right, so I'll just erase this here. I'll just erase this thing here. Right. So whenever we are talking about primary chiral, right, in case of primary, it should be chiral, okay? So, if you have Cl here, right? Cl here, then this H is different, this is different, this is different, that is different, that is chiral. If Cl is here, then also H is different, this is different, this is different, then also it is chiral. If here you replace Cl, CH2Cl, then you can't say this is chiral. See, simple thing is, if you replace this CH3 with the Cl, right, then you can't say this is chiral, because this carbon that has the chances of being chiral, that is having 2 methyl groups here, right? So you can't say this will be chiral. If you use from the primary hydrogens, if you replace this hydrogen here, then you can't say that this is giving you the exact thing here, right? So that means chiral is not possible in this case. Chiral is not possible in this case. If you replace this thing here, CH2Cl, then this will be chiral, this carbon will be chiral. Or you replace this thing here, that is CH2Cl, or this one, then it will be chiral. That means with the Cl, if you want to replace hydrogen with Cl, only 6 possibilities are there, right? Only 6 possibilities we have. And can you tell me what are the 6 possibilities? The 6 possibilities are these 3 hydrogen and these 3 hydrogens. Only then you can have the chiral carbon here, right? Okay, monochloride, which is chiral, right? So that means out of this also only 6 are giving us the chiral. So it will be, percentage is going to be 6 divided by, total we have 9 plus 6 plus 5. Okay, so it will be 9 plus 6 plus 5 multiplied by 100. That is going to be your correct answer here. Okay, understood? Everybody, is that clear how we are going to answer these kind of questions? Okay, so that is how you are going to answer this. You have to see each and every single word here. That is, chiral is given to you. That's how you will answer that, right? Is that clear to everybody? If there is any problem, then let me know in the chat box. The answer will be 30% is going to be the correct answer here after solving, right? Okay. Next question is, you have this compound where you are doing H3PO4. You are adding H3PO4, right? Total number of alkanes and number of fractions basically. So whenever you have H3PO4, that is a very good dehydrating agent, right? So that means it is going to dehydrate, and they are asking you the number of alkanes and the number of fractions of Y that is obtained, right? So dehydrogenation you have to do. So first thing, we know that whenever we are taking out, when we take out OH from here, there will be a positive charge here, right? So that means this will be the carbocation that will be formed here, right? Chances are either directly what will happen, either directly from here, because you need to have a stable carbocation, for that shifts can also happen here. But from this position, 2 things are possible. From here, directly you will heat it, this, because here you don't have any hydrogen. Here you have 1 deuterium, so this will be lost, and here you will have a double bond, right? So double bond will be formed here. One thing is this thing, okay? First thing is this is possible. Other possibility is, because ethyl has more migration as compared to methyl, so this ethyl can directly migrate to this position, right? C2H5, and here you will have a carbocation. That means ethyl shift can occur, and you will have this shift here, this carbon having positive charge, 2 methyl groups, and this carbon having ethyl and CD3, right? Now here again dehydration will occur. Okay, so you have carbocation. One thing is, because here you have only one deuterium that it can lose, right? Either this alpha, this is alpha, this alpha only has the hydrogen isotope, this does not have any hydrogen or any hydrogen isotope. This has two cases, either this hydrogen can leave, if this hydrogen or this hydrogen, let's say, because both are symmetrical, or this hydrogen leaves, you will have this as your answer. That is a double bond over here. If this leaves, double bond over here. If this leaves, double bond over here. Right? Both are symmetrical. Right? So this will be the second product that can be formed here. Right? Third is, it can also lose H positive from this position and double bond is formed here. So this is the third possibility that you can have. So three possibilities we have here. Total 3 alkenes are formed after fractional distillation. 3 Ys are separated. That means 3 number of fractions what you will observe. 3 fractions can be observed in the end. So answer will be C is the correct answer. That is 3 are formed and 3 are separated here. Right? Okay. Next we have, in this question you have a, let's say, a reaction, a reagent you have. And this is showing SN1. SN1 means again they are telling you that carbocation formation is there, right? So, and you are adding CH3ONA, CH3OH. That means in this case, first thing is you have this O double bond here, right? So this is a lengthy question, okay? This will be a very lengthy question. So many things will happen. So see, first thing is, when you do this, it is going to, because it is going to form a carbocation, right? So it will cause elimination reaction here. So Cl negative will be eliminated. You will have the formation of a carbocation, right? Now see this very carefully. So when you have the formation of a carbocation, just like in the previous what we did, first thing is directly what can happen, OMe can get attached to it, right? Because what you are doing here, you are adding here OMe, right? So that's why OMe is the nucleophile that can easily get attacked here, right? Okay, so that will easily get attacked here. That is the one case. That is the first product that can be formed here. Or carbocation can also do the rearrangement. So what you have is double bond, single bond, positive. So what can happen? This double bond can shift here. This will be double bond CH2 and positive charge can be over here, right? Positive charge can be over here. In this also, OMe can get attached and you will have OMe over here. Till here, just see this, that OMe will be present here, right? Again, what can happen? Positive, single bond, double bond. Again, what can happen? Resonance. So double bond will be shifted here. You will have a positive charge here, right? Double bond is shifted here, positive charge is here. Again, here OMe can get attached, right? So we know that 3 attachments of OMe are possible. This possibility, and this possibility. Now we will see any further rearrangements can happen here or not, right? Okay. Here what you will see. This is OMe, this is lone pairs, this is single bond, this is double bond. Now students, what you will see, that here directly what will happen, this double bond by tautomerism, this height, let's say this is 1, this is 2, this is 3. Okay, just put this value. Okay, this is 1. Here also you can put the same. Chalo, I'll do this way only. Double bond. Okay, firstly let us see this. So firstly here what you will see, double bond is attracted to this side. Hydrogen is shifted here. See, double bond will be shifted to 2,3 position. Hydrogen is shifted to the first position. So double bond is shifted here and that hydrogen is shifted here, and hence you will have the, because can you tell me the reason here? Okay, who will tell me the reason here? See, we know that this compound here, this is 1, 2, 3, 4, 6 pi electrons. This is aromatic, right? This compound in the initial phase, this was aromatic. You are breaking the aromaticity here. So whenever you break the aromaticity, that becomes unstable. Nobody wants to be unstable. Aromatic compound is maximum stability compound. So they will try to regain their aromaticity. That is the reason this bond will shift here. these electrons will shift here, you will have a double bond here, and hydrogen will shift here, and this will be the answer that you will have, right? Okay, after this what will happen? Again, this is non-aromatic now, no complete conjugation. Again, the bond will shift here, this bond will shift here, make a double bond, this bond will shift here, make a double bond here. You will have one double bond, and hence you will have OMe here. So remember that aromaticity it wants to gain. So in the end, what you will see, here you have CH2OMe, here you have CH3OMe, here you have CH3 and OMe here. So these are the three products that can be formed here, right? So all of them can be formed. So answer will be all of these is the correct answer here, right? That was a very, very important question, right? Very, very important question. Students tend to make mistakes here, right? Next is consider the following sequence of reactions. So this sequence of reaction is given to you. This might seem difficult to you, but it's actually not difficult, right? You can easily solve this with full concentration. It's not a difficult question, right? You just need to apply some common sense here, right? So here it is the electronic configuration of element X, that is Ne. So this is talking about sodium, right? It has nothing to do with sodium. Then which of the following order correct given enthalpy? So if you see this here, first thing is given to you, delta H4 and delta H5 are equal. Delta H4 is this thing, delta H5 is this thing. They are saying that whenever you gain one electron, right, it becomes Na negative. And when it lose one electron, it becomes Na. Both the enthalpies are equal. That is true. Can you tell me the reason here? Because it's not like Na negative is very highly stable than Na. It's not the case. That is why even after gaining or losing the electron that you have gained, right, that will have the same amount of enthalpy. That means that is the correct thing, right? Then we are saying delta H2 is greater than delta H1. Delta H2 is greater than delta H1. So this is first ionization enthalpy, first IE1, this is IE2, this is IE3, right? We know that as you form cation, it is difficult to lose the electron. So we know that delta H3 will be largest, then you will have delta H2, then you will have delta H1. Because from a neutral atom, it is still easy to take out electron. But as you go to the charge increases, it is difficult to take out the electron. So that is the reason this delta H3 has the max difficulty, right? It has a very difficult to lose the electron from a very highly positive trivalent cation, right? So that is why delta H2 is greater than 1, that is correct. Delta H2 is greater than delta H3, that is not correct. Okay, so delta H1 and delta H6 are equal. Delta H1 and 6 are equal, definitely. When you lose the electron, see, we know that Na positive, right? When you lose the electron and when you gain the electron, they are also going to be electron. You lose it, you convert it back into the same neutral state, that is also going to be the same. So answer is A, B, D, all of them are the correct answers here, right? Okay, understood? Next we have, okay, next I think we are left with last two questions. This is what I believe, one, not two, yes, last 2-3 questions we are left with, right? Okay, so here let us see 11 moles of N2. So N2 is given to you, H2 is given to you, right? Two things are given to you, N2 and H2. 11 moles of N2, 12 moles of H2 are mixed in 20-liter vessel at 800 Kelvin. After equilibrium was reached, 6 moles of H2 was present. Okay, right? Initially you had 11 moles, this is 12 moles, right? These are the things that you need to, after equilibrium was reached, 6 moles of H2 was observed. Okay, so one thing I can directly say here, N2 plus H2 give rise to NH3. We know that this is going to be 3, this is going to be 2, right? So now they are saying that initially you had 11 moles, right? And 12 moles of this was 0, right? Now one thing to understand here, if you take out 11, let's say X moles are getting replaced, this is 12 minus 3X, this is 2X, right? Now they are saying that at equilibrium 6 moles were present. So can I just equate this thing? 12 minus 3x is equals to 6. So 3x, that will equals to 12 minus 6. So that is 6 only. So x will be equals to 2. So can I say that this 11 minus 2, this is 11 minus 2, that is 9. So this 11 minus 2 will be 9. This is 6 only. This is 2 into 2, that is 4. Okay. So that means now I have the equilibrium concentration of all of them. Right? Okay. Till here we know. After this, 3.5 liter of liquid was water. Liquid water was injected in the equilibrium mixture. This is the volume that was injected, right? And resultant gaseous. See, initially what you had? Initially you had 20 liter of vessel, right? Then they are saying 3.58 liter of liquid is injected in the equilibrium mixture, and the resultant gases mixed suddenly cooled at this. Okay, what is the final pressure of the gaseous mixture? See, we know that initially you had 20 liter of initial condition, you had this thing, right? So this much was injected. So you can subtract the volume here. You will get the volume at the equilibrium phase. Pressure is what they are asking you. Final pressure of the gaseous mixture. So we know that PV is equals to nRT. So P is equals to nRT by V. Volume we can easily calculate. 20 minus 3.5 volume can be calculated. Now they are saying assume something. Okay, let us see what they are asking you to assume. All NH3 dissolved in water. That means when we are calculating the number of moles, N when we are calculating here, we don't have to assume NH3. That will not be taken because that is dissolved in water. So in that, what you see, total number of moles will be 9 plus 6, that is 15. 15 is the total number of moles at equilibrium. Okay, that you should know, right? No change in the volume of the liquid, no reaction of N2 and H2. That means they are inert. There is no acid reaction between them. So number of moles are, you can know, temperature is already given to you, right? Cool to 300, right? And volume also we can calculate 20 minus 3.58. Easily you can find out the value here, right? So volume of vessel available for gaseous mixture of N2 and H2. Why? Because equilibrium is taking 3.58. So volume N2H2 that we have in the mixture 9 and 6 moles. They will have how much volume? 20 minus equilibrium. This is at equilibrium. This is initial. This is initial. Initial minus equilibrium is volume is given to be this. So directly pressure is equals to N R T and this is the volume. Okay. So that's how you will calculate the volume here. Pressure here, and answer will be C is the correct answer here. Right? Okay. Next, let us see. Next question here. Next question, let us see. The value of Kp for the reaction, this is the reaction, and the value of Kp is given to you, that is 1 atmospheric, right? For this Kp value is given to you, that is 1. We also know that Kp is equals to pressure of BrCl raised to power square, that means raised to power 2, divided by pressure of Cl2, right? At least write what you know, right? At equilibrium in a closed container, that means in a closed container, partial pressure of BrCl is 0.1. Okay, so closed container, partial pressure of BrCl is given to you, right? At this temperature, vapor pressure of Br2 is also 0.1. Okay, then what will be the minimum moles of Br2 liquid that to be added to 1 mole of initially to get above equilibrium situation. Okay. Now they are saying at equilibrium BrCl2 is 0.1, right? And at equilibrium only we get the value of Kp. So we can say that here if you put the value of this is as 0.1, you can get the value of pressure of Cl2 at equilibrium. Initial is given to be 0.1. Initial is given to be 1. At equilibrium, you can calculate the pressure of Cl2, right? Okay. Then they are saying that in a closed pressure, BrCl gas is 0.1. Okay. So one by one we will solve this. First thing is, we know that this is the pressure. We know that this is Kp is equals to P of BrCl square PCl2, right? This is given to be 1. Pressure of BrCl at equilibrium is given to be 0.1. So you can calculate the pressure of Cl2 at equilibrium. I'll just mention here, this is at equilibrium. Pressure of Cl2 initial, that is given to you. I think initial moles are given to you. Moles are given to you. Okay, not pressure, moles are given to you, right? So pressure is also, you know, at equilibrium, initial moles also, you know, right? Now, talking about this thing here, rather than this, I would not advise you to write it like this, right? Let us see what we are going to write here now to solve this equation, right? So we know that liquid, we don't see this. So this is given to be 1. This initially will be 0. This will be 1 minus x. This will be 2x, right? Now, if you want to calculate the value, like let's say you are putting the value of Kp, PBrCl is 2x. This will be 2x raised to power square, and this will be 1 minus x. From there, you can get the value of x here, right? Okay, so that easily you can get, either you can do this thing or you can get the value from that. Now, in a closed value, in a closed container, we constant and temperature is also constant. See, we know that PV is equals to nRT. They are saying this is constant, this is constant, this is constant. So pressure is directly proportional to number of moles. So pressure, we have only two things. One is BrCl and one is Cl. So the ratio of these two things will be equals to ratio of number of moles of BrCl and number of moles of Cl2. Number of moles of BrCl, right? That we can, how you can calculate that? We know that the pressure is 0.1. This pressure we have calculated is 0.01, right? So just put these two pressure here. You can get the value of, number of moles, and this also is given to you, right? This also, if you put all these values here, no? So this at equilibrium is given to be 2x. This is given to be what? This is given to be 1 minus x. Okay. So at equilibrium, you know all these values. Okay. This is 0.1, this is 0.01, 2x and 1 minus. From there, you calculate the value of x, that is 5 by 6. Now, once you calculate the value of x here, this will be 2 into 5 by 6, that is 10 by 6. This will be 1 minus 5 by 6, that will be 1 by 6. Okay, that is going to be the answer, 1 by 6. Okay, this you have taken out to be 1 by 6, this is 10 by 6. Now, see one thing, they are asking you what will be the minimum moles of Br2 liquid that is to be added, right? So for Br2 liquid, what you have to see here, that so number of moles of BrCl is 10 by 6. Since the vapor pressure of Br2 is same as that of partial pressure of BrCl, this is given in the question. Okay, if you see, this is given in the question. The temperature, the vapor pressure of this is also this. So vapor pressure is 0.1. That is same as the partial pressure is also 0.1. Vapor pressure is also 0.1. So when the vapor pressure of this Br2 liquid is equals to the partial pressure of this BrCl, that means the number of moles also will be equal, right? Because in the solution, the number of moles, that means also same. So you can say that the number of moles, we can say that the number of the vapor pressure is equal. So you can say that, I'll just write, number of moles of Br2 will also be 5 by 6, right? Okay, equal to BrCl. So you can easily write the number of moles here, right? Number of moles of Cl2, right? Now you tell me here how much amount is left to you. Cl is left is 1.5. How much Cl you have used? Now see this equation, you have a bromine in liquid. Here you are using this Cl you are using, and then you are getting this, right? Now the minimum Br2 that is required here, that will be equals to how much you have used and how much you have formed here. Addition of this, how much you have used Cl2, how much Cl2 you have used here, because the amount of Cl2 that you have used is equal to how much it is reacted with Br, right? So that is equal to how much Cl you have used and how much BrCl you have formed, the addition of both the things. So how much Cl you have used is 5/6. How much BrCl you have formed is 10/6. So this is 10/6 plus 5/6. That is going to be 15/6 is the correct answer. That is the minimum Br2 that is required here. Right? Okay. Understood? Right, everybody? Is that clear to everybody or not? That is a very, very twisted question. Right? Okay. So a very, very important question of physical chemistry. Right? Now let us see. See, from organic chemistry, usually questions are not lengthy. They are more conceptual based questions. If you know the concept, you can answer that in seconds. In physical chemistry, the questions are more on the lengthier side, right? So you can see acidic hydration we are doing. So what will happen? So here what you have to know, directly you can't answer this. So first we know that acidic hydration means this ET will be replaced by H here, right? Okay, and this Me will also be replaced by methyl groups are replaced by hydrogen. That is what we do in acidic hydration, right? So here you have OH. We know that here what will happen? One carbon cannot hold it, so water will be eliminated. Here you will have double bond O, right? This is the situation that you will have here. After this, till here you know that it is correct. But after this, you need to remember that when you have beta keto acid, right, beta keto acid, that will easily undergo. So on this position, what you can see over here, right, so you have C double bond OH, C double bond OH, right. What will happen here? Both will undergo decarboxylation. Carbon dioxide will be eliminated, and hence you will have the formation of this ketone, right? Okay, understood? So that was the important point here. The last step was very important, right? Last step was very, very important, that it will undergo decarboxylation in the acidic medium, right? Okay, I think this is the last question of today. The question says that following is the titration curve of two acids HA and HB, right? 5 millimoles each titrated against strong base. See, everyone has different way of solving. You can also solve it by these like proper numeric method that you can apply here, or directly you can know that directly from the graph also you can solve from the following type. See, if you solve it from detailed method like full numerical method, it will take you time, right? So some tricks also you should know for JEE Advanced, especially for chemistry, because that is going to save your time, right? So here it is, following the titration curve of HA and HB titrated against strong base NaOH. What is the pKa of HB? So this is the HB curve that you can see, right? We know that this point is the equivalence point. This point is the equivalence point. Now remember that pK, this just thing you need to know, is equals to pH half equivalence point. Equivalence point. That means the pK will be equals to pH, the pH that you have, because this is the pH that you have on the half of equivalence, because this is equivalence, its half will be this line. This is the half. Now HB has what pH? The pH of HB is nothing but 5. So answer is going to be 5 is the correct answer. Okay. Either you can directly solve it like this, the method that I have told you, or like if you find this like, ma'am, I don't know if I'll be able to apply that or not, then you can solve it by this method, that from titration graph of this, what we can observe that the volume is 25, like see, on this position, right over here, right, you always have to see the half of the equivalence. This is the half of the equivalence, which is showing you 25 milliliter, right? Okay, 25 milliliter is the volume. pH here is given to be 5. pH here is 5, right? Then number of moles. See, initial number of moles is 5, and because we are doing the half of equivalence, so number of moles will also be half of this initial moles, that is 2.5. That is 2.5. So number of moles of NaOH will be 2.5, right? So this is HB, NaOH and NAB. Initially you have 5, this is 2.5, this is 0. You take out 2.5 at this time of equivalence, right? 0 will be left here, and here you will have 2.5, right? So you will get to know that, okay, when you apply this, pH is equals to pK plus log of, now salt is what? Salt is 2.5, acid is 2.5. So 2.5 by 2.5 cancel. So pK is equals to pH. You can even numerically solve this. You can also do this with the help of graph. Totally your choice. Okay? Yes, everybody? Right? Okay. Yes. Practice is the key, students. Practice is the key for JEE Advanced, right? The theory is not going to make anything. If you more do practice, more you will be able to answer the questions. And for practice, we also have this group you can see here, right? If you see this over here, wait a minute. Over here, what you will see, that JEE Rank Accelerator book is there, which is dedicated to practice the questions, okay, of physics, chemistry, and mathematics, right? Even now you have time if you want to dedicate your time to one book, that is Rank Accelerator book, and all these questions are from Rank Accelerator book, okay? Very interesting questions that are of JEE Advanced level, so that you will be able to answer those questions in the exam as well. You don't have to trick your mind in the exam that what is happening here, right? So you should be aware with what kind of question they can ask you, and for that you need to practice these books here. Next is here, what you will see is the Eklavya batch. So that is also for JEE Advanced students, right? So here we prepare the students for JEE Advanced, right? So if you're not able to solve the questions yourself, like I can see in the comment section, so many students are saying, see, one thing is you can purchase the book, solutions are given to you. Most probably you will be able to understand from the solutions only, right? But still, if you feel that, ma'am, I still need a teacher, I still need someone to guide me through that, then you can go for Eklavya batch, where we are solving these questions, previous year questions, right? Doing the practice, doubt session, everything is going on right now in that batch. So you can get yourself enrolled to that batch, right? Okay. And for all the students who are preparing for, let's say I was seeing some students who were preparing for 2026, 2027, then students, for you, we have Vedantu offline centers. So you can see this over here, Vedantu offline centers, and I'm also coming to Vedantu offline center at Chennai. So I'll love to meet you guys on 6th of May, right? So I would really love to meet all of you there, right? And here if you see, offline JEE and NEET repeater batch that has already started from 25th of April. So here 40% scholarship is right now going on, depending upon the various factors. And if you want to avail 90% scholarship, then go for IV SAT test, that is Instant Vedantu Scholarship Admission Test, right? You have to give this test in the offline center to avail 90% scholarship and more, right? So that is that, depending upon your result, you can avail that. Ma'am, where is the link that we can get? So you can get the link of the admission over here, IV SAT. Click on this one and you will get to the portal where you can get 90% scholarship according to your results. Okay. So that's it for today, students. Bye-bye. Take care and let me know in the chat box what exactly you are looking for, 2026, 2027, or the students of JEE Advanced. Let me know in the chat box. Bye-bye. Take care. See you all in the next class. Bye-bye.